Example 1, manufacturing. A factory of the global manufacturing company was manufacturing products with a defect rate of 15% based on data from the Harvard Business Review. If a customer purchases 12 of the products, what is the probability of getting at least one that is defective? Now, step 1, we're going to let A represent at least one of the 12 products that's defective. In step 2, we want to identify the event that is the complement of A. The complement of A is equal to not getting at least one defective among the 12 items, which means that all 12 items are good with no defects. Then step 3, we're going to let A equal at least one of the 12 products that is defective. So the probability of the complement of A is equal to the probability that all 12 items are good. So if we know that there's a 15% defective rate, if we take 100% minus 15%, which is the same thing as 1 minus 0.15, that gives us 0.85. That means 0.85s would represent each item that is good. So since there's 12 items, we're going to multiply this 0.85 12 times. Another way of writing this is 0.85 to the 12th power, which gives us a decimal of 0.142241757. We want to round that to 3 decimal places to get 0.142. And so now what we want to do is we want to find the probability of event A by evaluating 1 minus the probability of the complement of A. So the probability of A, which is equal to 1 minus the probability of the complement of A, is equal to 1 minus what we found in the third step of 0.142, which is then equal to 0.858. So the interpretation would be the following. For a group of 12 products, there is a 0.858 probability of getting at least one that is defective. As quality controls goes, this is too high. The company needs to improve its manufacturing process so that the defect rate is lowered.